Satish sir, good afternoon.
Satish sir, good afternoon.
Good afternoon. Good afternoon.
Good afternoon, sir. Sir, just I'm correcting YouTube, sir.
Hello.
Yeah, I'm correcting YouTube, sir. In 2 minutes I will
In
start.
2 minutes I will start, sir.
Okay.
Sadish, good afternoon.
Good afternoon. Our session is at 3:30, isn't it?
Sir,
No, right now.
right now,
Oh, right now. Oh my God.
Satish sir, can we start, sir?
Hello.
Sir, your YouTube live has given, sir. Please ready. Sir Satish sir, can we start?
Satish sir, can we start,
YouTube
sir?
live has given.
YouTube live has given.
Hello, Venvis.
Yes, sir. YouTube Live has given chat. Now I will start the programs.
Oh, okay,
Okay, sir.
okay, sir.
I will.
First speaker.
So,
What's the range?
sir, first speaker is Somsekharan, sir.
Somsekharan. First speaker.
Yes. I will start, sir. Very good afternoon. Very good afternoon to all the participants in the Google Meet and YouTube Live. I'm very happy to have you in the Day-2 Session-4 here. Now here in the Session-4 we have three lectures. So the first two lectures will be chaired by Dr. C.Satish, sir. Happy to introduce Satish, sir. Sir is currently Professor and Chairman PG Board of Studies, Department of Statistics, University of Kerala. Sir formerly head the Department of Statistics, University of Kerala. Sir has his academic qualifications, MSc, MPhil from the University of Kerala, the Department of Statistics. Sir is having 120 research papers in peer-reviewed journals, and he has been published books in Advances in Statistical Analysis in Madurai. He guided more than 8 PhDs and more than 32 MPhil scholars. He has supervised more than 38 MSc projects. Currently he is having 8 research scholars and 3 MPhil scholars. So he is having more than 5 years of industrial research experience and 30 years of theoretical research experience. So presently he is a member in most of the technical advisory committees. He is also the editor in Asian Journal of Statistical Sciences, Associate Editor in Journal of Indian Statistical Association. So he is also the executive trustee of the Mathematical and Statistical Science Trust 2021. So he is a Senate member of Kerala University, Academic Council of Kerala University. He has various academic and administrative positions in university and in the government bodies. I am happy to introduce you, sir, and I am requested to chair the session. Thank you, sir.
Thank you, Venkatesh. It's a wonderful what you are talking today. In fact, I'm very much happy to be here in this gathering of our today's this session, especially because we have a very good speakers. I'm trying to chair this session, and the first speaker, in fact, Somsekharan Pillai. Professor Somsekharan Pillai is in fact very active, especially in the data analytics area, and he is presently the head of the department of our University Department of Statistics, University of College, Trivandrum, and he has more than 25 years of teaching experience, as well as in fact several publications he has, and several involved in several conferences, workshops, and a member of the academic council, several board of studies, and several he's an expert committee member in several governmental assignments, and a person like him, and you can understand, you can see what after talk you will say his expertise. I'm very much confident, and I'm very much proud to introduce a person like him. More than that, he is like an elder brother. I utilize this occasion to invite or to welcome Professor Somsekharan Pillai to carry on this session. Thank you for ISPS to give a chance to chair this session. Once again, welcoming Professor. Please.
Thank you, Professor Dr. My friend. Okay, I am getting into the presentation because we have only a very short time. And today, my topic is design of experiments analysis using R. I am just presenting what are the things I am going to take or going to handle. So, within a very short time, like 45 minutes, I cannot go into much details of analysis. But today I plan to complete this much topics, how to analyze the completely randomized design data, the linear models, and this analysis. So in R, how do we check the data assumptions, graphical procedures, and how do we apply the transformations, box point transformations, and the randomized plot design, and factorial designs. And if time permits, I hope I can complete all these things. Then I have the data and codes in R. I will run it because short of time I already make it ready. And so I use the R-based system. Yeah. Okay. I use the R-based system because it is very simple. Then, so I already have the code. The first one, how do we analyze the CRT data or one-way ANOVA in R. So here in the first example, I have a treatment factor having 3 levels, 30, 35 and 40. And these are actually, in fact, I think of most of the participants are postgraduate students. I have been taken a simple example of effect of fertilizer on yield. And there are 3 levels, 30, 35 and 40. And the yield data is given. In this case, there are 6 replications. And first we have to categorize this data or factorize this data. We have to instruct the software that these are factors. So in R, we can use the command factor to learn the system that this is a factor. This is a factor. Yes.
Sorry, someone interfered in the presentation. Please, Balaji, please do not present. Please stop your presentation, Balaji. Our speaker is present.
Okay then, thank you. Then, okay then, I use the command factor. Rep is a command, replication, C command. So I have been using several commands in this one step. So C is a command to input data in R. Here the different values are 30, 35 and 40. I have been using the C command. And this command instructs to replicate these values each 6 times. And make it a factor and copy it into or store it into a variable name FT. Okay. So FT is factor of RAP. Replicate the data 30, 35, 40 each of the 6 times. Once we run this one, we can see the output in the console. The console you can see these are the values of the factors 30, 36 times, 35, 35 6 times, 40 etc. 6 times. And it given that there are 3 levels 30, 35 and 40. Then next I input the data of the dependent variable. The dependent variable here it is yield. So these are the values of yield. And first I will show you how to do it by a linear model. This command is very simple. In order to construct a element LM, which is a short form of linear model, then the dependent variable, that is yield, the tilt operator and the factor. Okay, the factor is F. So if we run this one, okay, it is executed, there is no error. This is the linear model. And in order to view the output or the summary, you can use the command summary. Summary is the command which can be output of this linear model, which is stored as modic. So if we run it, you will get the output. Okay. So So which gives the minimum value, the first quartile, the median value, the third quartile, and maximum value, hence the intercept. And this factor level 35, its estimate is there, 40, its estimate is there, and here we have been taken the reference category as 30, and its standard error is D value and its P value. And in all these cases, the P value is less than 0.01. So these are significant with refer to the category 30. And you can see the highest value estimate obtained for the level of a laser at 40, okay, 12.667. And for the category 35, it is 6. And these two values are in reference to the first category 30. Moreover, it gives the residual standard error, then R-square value, which is 0.838, and adjusted R-square value 0.8163. It indicates 81.63% of the variation is explained. Variation of the yield is explained by this treatment factor, and the F statistic value is given 38.78, and the degree of freedoms 2 and 15. And the P value is less than 0.01. So this model is significant. Okay. So this is very simple. It is very simple to construct a linear model. In R, the command is LM, linear model, and the dependent variable. Then use the tilt operator and then the factor. Okay, the factor variable. Okay, here I use the data as it is given. Then suppose for students, we want to take a sample on this data, take a sample of this data. This is the one I have been taken in the specific order. And how do you select a sample on this factor? Suppose I have to do some randomization on this factor, then you can use the command sample. So in order to use this command sample, you can, these are the commands. You can set seed with some value. Then I just run it. Okay. Okay then. So you can use the command fertilizer. That now it has been taken a randomized rate. So now the order has been changed. The command is sample. Then the variable ft, that is the factor variable, and 18 observations. So what it has been done is the original factor level order has been changed, or it has been randomized. Now the original factor value is in different order. Naturally, the analysis will be a different one. Okay, this command, I am just showing this command only to familiarize how to take a sample on a given set of observations. Okay. And if you use this sample data, then now I stored that factor into another variable FERT. And I use another model, that is the linear model with the variable yield, tilt operator, FERT. Okay, and using this randomized factors. Now you will get another result. Here you see. Now the data completely changed. Now you get another output. Okay. In this output, you can see the R squared is 0.1028. Adjusted R squared is some values. I am just showing this to only familiarize this command sample. Okay. But I stick on the analysis on the original data, the original values. This is the original value. So now, how do we analyze it using one-way analysis of variance? In order to do an one-way ANOVA in R, the simple command is AOV. Students are attending, they can note it. The command is AOV, analysis of variance, short form AOV. Then what is the syntax of that? The dependent variable and the tilt operator and the factor variable. Okay. So I use the command AOV, yield, tilt operator, FT, and stored that into another variable mode 3. Okay. I'm just running it. Now You see? Okay. If there is any error in the console, it will show the error message. So here the command is executed, so there is no error. Okay. Now let us see what is the output of this one by executing the command summary of the output of AOV command. Okay. What is the output of the AOV command? Mode 3. And let us take the summary of this one. Yes. Now you see this is the analysis of variance table. This factor variable ft, its degree of freedom is 2. Okay, residuals is there. In fact, this is the between sum of squares and within sum of squares. The sum of squares are given 481.8 and the residual sum of squares is 93.2 and the mean sum of squares is there, f value and p value. And since p value is less than 0.01, so there is significant difference in yield in between the levels 30, 35 and 40. Okay. So this is the usual method we do analysis of variance or analyze the CRD in classrooms. Analyze CRD in classrooms. Okay. Then in order to analyze a practical data or a real data, we have to do something more. Because in a CRD there are some data assumptions. So what are the data assumptions? The first one, the data should follow normality, normal distribution, with a constant variance, that is called homoscedastic assumption. Okay? So the data must satisfy these two conditions, so we have to check whether our data satisfies these conditions or not. If the data has not satisfied this condition, then we have to go for some pure measures or transformation, etc. Okay? So I shall repeat again, please listen the students here. This is a simple example of a CRD data. This is the experiment. We applied 3 levels of a fertilizer on a particular variety and the yields are measured. The data is given. Then this data is stored. And since the values of these factors are numerical, we have to instruct the system that this should be taken as a factor variable or a categorical variable. So in order to instruct that, we can use the command factor, and this RET can be used to replicate a data. Okay, so there are different type of formats there, different syntax is there, and the first command is used to educate the system that this is a factor and these are the factor values. The next is the dependent data. Then you can estimate the parameter values using the LM command, and the analysis of variance can be used in AOV command. Okay, AOV. Then next I will use some graphical procedure to check whether the data satisfies the assumptions or not. So these are the commands. I use PAR PROF.C.R.RAO. This is just to define the graphical area by a 2x2. Okay, and plot the values of the mode 1. Okay, mode 1 was the output of the first data, and mode 2 output of the second one linear model, and I just take the mode 3 ANOVA model. I use 3 different plots. I plot mode 3 is equal to 5, mode 4 which is equal to 1, mode 3 which is equal to 0. So this which is equal to 1, 2, 3, 4 value gives the different kind of graph. Plot residuals of mode 3. Okay. This is observation variable, observe. So actually this variable is just to show the serial number of the numbers in order to get the individual observations. Okay? Because in graphical procedure we can generate charts with respect to the individual observations, chart process. So for that I use the command, the last one, plot residuals of versus the number of observations. This is the plot observation versus residuals. That means the first level, this is the variation of the expression, and it is residual. Second one, it is more scattered. Third one, also it is almost same. So you can see that the within variation of the first category is comparatively less than the variation of the second and the third. Or you can see that the variation getting factor down. The next one is residual versus fitted values. These are the fitted values, these are the residual. Here also you can see that the constant variance of some straight line and variance get increases with particular prediction. And the third one is a normal condyle plot, normal PT plot. So what it means is, so this line is all the values are exactly on this straight line region in the data is normal. And here you can see that the data is almost normal, and there are only two values, 13 observation and 18 observation, which deviated from this line, but it is almost normal graphical procedure. So this graphical procedure can be used to interpret the data. And here I use the different kinds of 5, 1 and 2. If I change these values, you will get a different form. Otherwise, 3. Again I run it. Now you will get a different form. This is another standardized scale location. This has been changed. I changed this to the okay. And again, if I change it into 4, you will get a different one. I don't know how much you are clear about hoop distance. So this hoop distance can be used to find out the influence of each observation on the model. Influence of each observation on the model. So the highest observed value is the 7th one, the 13th one, then the 18th one. Okay. So different types of graphical procedures are available. It can be used to study the effect of normality. We can check the heteroscedastic problem. Once you studied this graphical procedure theoretically, then it is very easy. You can learn all these things. It's very easy to check all these things. So this hoop distance is a procedure to find out the effect of each observation. Okay. So these are the graphical procedures available in our. You can change this value, you can try, if you get this odd, you can try it with the changing the value. Then, next, this is this data may not be perfectly normal, so if the data is not normal, what we can do? So I use the box plot transformation. You know the box plot transformation is a transformation something like that, y raised to lambda. So by choosing the value of lambda, the power transformation. The lambda is -1, it is a reciprocal transformation. Lambda is 1/2, it is square root transformation. Lambda is 0, it is a singular transformation. So depends on the value of lambda, you will get a different transformation. Okay? In general, it is actually the transformation is y raised to the ordinate value is y raised to lambda. Okay? So this is the transformation y raised to lambda. General formula. If it is -1, it will become 1/1. If it is 1/2, it becomes square root. If it is -1/2, 1/square root of lambda is equal to 0, we are substituting as logarithm. And these things will apply only for positive values. For negative values, there is another formula. value is maximum. It is not 0. It is log likelihood maximum is not at 0. It is some point just left of this lambda, isn't it? Okay, it is maximized, it is very near to 0. Then what should be the value? That value we can check. We use a command lambda AC $x which maximizes this likelihood. Give the value of lambda. So the lambda value is obtained as minus 0.020202. So this value you can see that it is very near to 0. So this is the way we estimate the most value of lambda. Fine. Once you get this value of lambda, you can apply the transformation on the data. So now I created a new variable yield raised to minus 0.020. Okay. So now I take or apply the transformation on the dependent variable, and then I do the ANOVA using the transformed variable by using the sign the command subscribe. So yield raised to minus 0.0202, and ANOVA on the dependent variable revenue. Now you will get this is the analysis. Similarly, you can see the model. Now let us see how far whether the R value get increased or square value get increased. Definitely. So this is the estimate, but you take care. This estimated value is the value after applying the transformation. So you cannot interpret this value as in the case of take care of that. Okay? You cannot say that this is the effect in reality, because we applied the transformation. Naturally, the estimate should be interpreted accordingly. Now, the multiple R squared value is 0.840, little more than the previous case. The previous case, the value was, I think it is 0.8. It was before that. The value was 0.838. So the multiple R squared value get increased. The model is improved by making the data more closer to the normal. Okay, then we may check again. Again we may run this graphical procedure and you can see the changes happen. The changes happen on this data. Now this I run it. Yeah. Now you see that regarding the normality there is some change happen. Okay. And here already the data was almost normal. Okay, then so not much change. So why I run this thing is to inform you these are the procedures we can. Anyway, the heterogeneity problem is there. How do you avoid the heterogeneity? So if there is heterogeneity, our OLS estimate is going to be the better one. Okay. Then we can use one procedure. We can use later square. Then square means we can apply different weights. Okay. So here I use the weight, the standard deviation. So there are different procedures to run the weighted least square. One procedure is to transform the data with the respective weight and run the analysis variance as before. Otherwise, you can use the command, the basic command in R, which is the weighted least square command is the AOV, dependent variable, then the switch operator, factor, and weight is equal to the weighted part. Now, let us output. First I compute the standard deviation of each dependent variable at each level. So I have to find out the standard deviation of the dependent variable corresponding to the first level 30, next 35, next. How do we apply this thing? Here you can use a command apply. What is this format? Apply the dependent variable, the factor variable, and then the method to be computed. Okay?
5 more minutes.
Okay. So here I use that one, standard deviation, and weight can be defined, replication of always standard deviation is equal to 6. And we can use to get the standard deviation. So directly you can get into the analysis of variance using this weight. Okay? Now you see, this is the analysis of variance, it is modified. This is the sum of squares 218.15 and plus 36.5. So the most important thing is, then let us check again this graph whether there is any change on the data. These are the codes which can be used to realize this ERD. So the other analyses are almost the same, but I will show you what is the difference. So in a ERD there is only one factor variable, but in the case of RPD there are two factors in RPD, two factors. For example, in the first case I use the fertilization at 3 levels. I add on one variable that is the variety of seed. The variety of seed is ordered out A, B, C. Okay? And both can be saved in two variables. And you see these are the, this is the dependent variable. And use the command. What is the difference? AOB is shift operator, first category plus the second category. We have to use the addition symbol in order to run the two-way number. Now you will get the two-way number. Therefore, between the fertilizer, between the variety and the material. And in this case, you can run this, all these assumptions getting and then the model kit, we can run the model kit also. Okay. LM command, we use the LM command, you get the model parameters estimates also. Then, yes, here the multiple observations are there. You can run the two-way analysis of replication. Previous case I completed the two-way without replication. In order to get the with replication, you can use almost SP into variety. Now add this one to run the interaction. Okay. So you get now the variable squares corresponding to the variety and interaction. So there is no interaction and only the fertilizer is. Now let us see what is the respective change in the factorial design. Here I have taken a B-square design. That is 2 factors each in 3 levels. So first you have to store the levels in the 2 variables. Here in a ethanol addition and air fuel ratio and the carbon monoxide ratio. The effect of ethanol addition and air fuel ratio on carbon. So both the categorical variables or factor variables to be stored in 2 variables. Like how we stored in EPS and the air. And this is the CO, this is the carbon monoxide. This is the data entity and this one. Now you see how do we check the ANOVA? The command is this one, AOV, the dependent variable CO, shift operator, then the first factor variable into second factor star. Just use simple star, then you will get the factor number. Okay? Now let us see what is the factor number output. Now you see the effect of ETH, then AFR, then this is the AB effect or the interaction effect. So this is the difference between the randomized block design and the factor design. In the case of RBD, we use the command, the first factor plus the second factor, but in the case of Madura design, we use dots. Okay? And you can run the linear model also in order to get the estimate. Now you see, you will get the estimate of each level. Okay? You cannot at level 0.2 in reference to the first category 0.1. Now at 0.3 in reference to the first category, the AFR ratio. Okay? Then that is 5.5. Next is 3. Then these are the combined joint effect of each one. Now 0.2 and 14. All the combination effects are known. To analyze the variance we already seen, you can see the R squared value is 0.9727 and the p value is less than 0.117, very significant. And in this case, you will get the individual effect and the joint effect. So I think I completed the time is finished. And I just introduced how to implement the R code of the designs. It is very simple for students because these commands are very simple. Using simple AOV command with the different syntax and very good graphical procedures are, and all the hard testing procedures are available to check the data assumptions and the querying methods, transformation, all these things are available. Still.
I utilize this occasion to welcome Dr. Ravan to SPSS. Yeah. Once again, I hand over this back to Dr. Ravan.
Yeah, good afternoon to one and all. First of all, I thank ISPS, Honorary President and President, Secretary and other members.
Sir, you can click on the present now, sir.
Yeah, you already
Yeah.
presented. Yeah. Just go to present now and then enter screen. Then that pop-up menu, you click on the pop-up menu, so that share button will be active. And click on that button.
They use this generally it is some difficult for sharing this.
Just click on present now.
Yeah.
Your entire screen comes there, isn't it? Okay, now it is coming. Now you can see your desktop. Now you can move to your slides. Notice you can move to your slide, or you can select. Yeah. If it is already open on the desktop, you can make it visible. Now it is possible for us to see your desktop of your computer. Yeah.
Present now, then window only I am selecting, but
Present now. It's better. First you open your slide.
Sir, that presentation should be open first. It must be open before entering into the session. Okay, that may be the problem.
already it is open. It is open.
Already you please open your presentation in the desktop and minimize it.
Everything open only.
Sir, before presenting that present now button, you go to your presentation and you click on that presentation. Then you come to present now.
Yes, now it is okay.
Now it is coming. Now it is okay. Now we can make it full screen.
Yes.
Oh, fine. We can continue.
It is structural equation model using AMAS. It's one of the very interesting topic and the most useful topic for those who are doing research in medical field. Not only medical field, any field. That structural equation model is the most important topic. Because what do you mean by structural equation model? It's nothing but advanced level of multiple regression. You know what is multiple regression? To find the cause and effect. We have some set of dependent variables, we have set of some independent variable. How that independent variable affect on dependent, that can be studied through multiple regression. But the structural equation model is nothing but advanced level of multiple regression. What do you mean by advanced level means? See, I will show some model here.
So your presentation is now not visible now.
Oh, wait, sir. See, now it is okay.
I know it is coming.
Yeah, I am taking one simple model here. I am taking this the general model. Same way you can try for your field, whatever your field. My topic is loyalty of consumer. I want to measure how loyalty of consumer for purchasing the product. Here I have considered so many factors here. One of the factors is purchase intention, perception, expectation, satisfaction, loyalty. There are these four factors leads to loyalty. If you put all four one by one, then connect directly to loyalty. That is nothing but multiple regression. Okay, but now I am not connecting all four with the directly to loyalty. First I am connecting purchase intention, perception to expectation. Now the expectation is the dependent variable. Purchase intention, perceptions are independent variable. This is stage one. The next stage, the dependent variable of expectation becomes independent for satisfaction. Now expectation, perceptions are independent, satisfaction is the dependent variable. In the third stage, the satisfaction of dependent becomes independent or loyalty. So if you want to run this model, we need three multiple regressions. One is purchase intention, perception on expectation, one multiple regression. The another multiple regression, expectation, perception on satisfaction. The third one is satisfaction on loyalty. If you run, we need three multiple regression through SPSS. But I want to run the whole model at a time through AMAS graphics. This is nothing but structural equation model. So this is one model. See the few another model here. I have this 5-factor leads to teaching skill. This teaching skill leads to teaching competence. So my topic is teaching competency. Whatever you want to reach, you have to put it on right side. Then what is the initiative factor? What is the mediating factor? This you have to decide by review of literature, based on review of literature. See here, my topic is talent management, organization efficiency. How to reach this through performance and industry state. These two leads to this 6 factors. My topic is work-life balance. Through organization support, security support, family support leads to work-life conflict, life-work conflict. This leads to work-life balance. This leads to well-being and commitment. Similarly, future growth. See here, this is the combination of CF and SEM, that is confirmatory technologies and structural equation. Service quality measured by through this 5 factors. But I have service quality is measured by through this 5 factors. Then this service quality leads to shopping experience, then loyalty, then customer loyalty. See here, perceived service quality and service recovery, both are unobserved variable, but measuring this 2 factor through many factor. See here, my topic is organization performance, but measuring organization performance through STM practices and competitive advantage, but measuring STM practices through this 6 factor. Competitive advantage measuring this 5 factor. This 2 leads to organization performance, but organization performance through this 3 factor. So this is nothing but combination of CF and DISM, that is called mixed set model. So before going for any result, this is called generally is called a scheme of for your result. Where do you want to start? Where do you want to finish? Suppose this model is already published in UK. You want to run the same model in Indian setup. That is one type of research. You have to put that model, put that reference in your thesis. Then it's not a problem. In this model, instead of expectation, if you change some other factor, then it is your model. Because in survival analysis, many factors influence on survival of patient or many models. In that case, you have to change some factor, then it is your model. Or add one more factor in this model, then it is your model. Deleting one factor is not your model. Either you have to change a factor or you have to add some more factor, then it becomes your model. So this model developed through review of literature. Okay. Now, based on this model, I collected my data. Sometimes in medical field, the secondary data is available. You can download the secondary data from hospital or wherever you can collect data, use the data and run the model. Or you have to prepare some questionnaire, and through questionnaire you have to collect data. Here, I have purchase intention, I have some set of some statements, some 15 statements, 20 statements in terms of 5-point scale. Perception, there are some 15 statements. Expectation, there are some 10 statements. Satisfaction, there are some 5 statements, 10 statements. Loyalty, I have taken only 1 statement.